Good afternoon. You're probably a little confused because on the previous presentation it said that I work for Wisconsin DNR, but these projects dragged on for so long that now I work for Fish and Wildlife Service as they've been wrapped up. But what I wanted to share today is a study that we just started last year, testing or examining depth selection by the Lake Trout morphotypes, specifically lean versus cisquet morphotypes. The lead investigator for this project is Rick Getz. He currently works for NOAA in Seattle and he was not able to make the meeting, so I was happy to present what we found. Basically, this is a collaborative project funded by Great Lakes Fish Commission monies. Like I said, Rick works for NOAA, but he's also still has a position at Milwaukee, and then Sean Seider from Wisconsin, Michigan DNR, and then myself from Fish and Wildlife Service. And actually, the Marquette Sea Lamprey station also contributed some resources toward this project so far. Multiple studies have shown there's a genetic difference between lean and cisquet morphotypes. Rick himself did a common garden experiment where he was able to show that leans and cisquets reared under identical conditions showed significant differences in growth, condition, lipid levels, and morphometrics. From years, decades of sampling, we know that generally they inhabit kind of two different portions of the lake. Certainly there is overlap between the morphotypes, but they kind of inhabit two different portions of Lake Superior. Furthermore, there's a lot of indirect evidence from diet, hydroacoustic surveys suggesting that cisquets do these vertical migrations, but we really don't know exactly how regularly those might be happening and if that's a common occurrence across many individuals. This depth selection, the depth habitats that they're selecting was presumed to be a genetic trait. On the flip side, it could be argued it's possible that it's environmental plasticity that's causing this depth selection. And this is especially relevant as we move these deep water forms and reintroduce them into other lakes. Will these critters behave the way that we expect them to when stocked in another environment? So the basic research question here was, is depth selection by Lake Trout morphotypes a genetic trait? We ended up using archival tags. Archival tags, a different type of archival tag, has been used to record depth and temperature selection by leans and to look at their habitat. The same has not been done for cisquets and some of the other morphotypes, which we might try to get into as well, but it hasn't been measured directly. It's been kind of informed through capture and primarily gill nets. But we were fortunate. Rick had these fish from other experiments that were done that were at a Northern Aquaculture demonstration facility. They had been raised under identical conditions, and now we're at a size, finally, that we could put these external tags on them, release them in Lake Superior, and see how they behave. Along with that, we would also tag wild fish as a comparison to those hatchery fish. So the tag, it's a pop-up archival satellite tag that we used. Desert Star Systems manufactures them. They've been used for many years in the marine environment. They hadn't been used in freshwater because the mechanism to detach from the external harness of the fish depended on salt water degrading that connection. Well, they've developed a way now where a different mechanism, which I'll tell you in a second, disconnects the harness from the tag. But they record depth, temperature, acceleration of the fish, and also, under the right conditions, geolocation of the animal. You can see from the quarter on the picture, the scale, they're good sized tags, and so we have to ultimately capture large adult individuals. We could program them to collect data at various frequencies as often as every minute. And then you can program the exact time of release from the fish down to the second when these tags would pop off. The tag, it's an external harness. We got the idea from a project that was done with Atlantic salmon for attaching them to the fish. They detach from the harness via a small explosion. So basically we put explosive material in a portion of, I should point out, on this portion of the tag right here. When it's programmed, when the mission program is done, small explosion severs it, the tag immediately then floats to the surface. It runs primarily on an internal battery, but if the fish or the individual is in the photic zone and receiving some light, then it will work off solar energy as well. When they float to the surface and begin transmitting, then they are primarily running off of solar energy. It's kind of unique. These tags are somewhat unique in the way that they determine position. It's a combination of how the individual crosses the magnetic field of the Earth, so it's got a magnetometer inside the tag, and then also the sun's position. And those two factors combine to give you a relatively high resolution in terms of geolocation. After it releases from the fish, it floats to the surface and immediately begins transmitting the data. I think initially it's packets or summarized packets of data, but then also eventually it's the entire raw data series is transmitted via satellites. So the beauty of these tags, even though they're a bit more expensive, is that we're guaranteed if they work as promised, we will get all the data back, and we don't have to depend on trying to recover the tags in those individuals later on. The next few pictures are just kind of showing the harness. Basically, two large hypodermic needles inserted on. We started at about midpoint, the mid portion of the dorsal fin, and then immediately behind the dorsal fin, and used heavy-duty fluorocarbon and kind of created this harvest. Again, the idea came from a similar use of a study using similar tags on Atlantic salmon, and so far they've worked pretty well for us. The fish are just being anesthetized, as we're working on that on them, and we actually got pretty good with it. We didn't have them out of the water for very long at all, so in the hopes that the overall stress on the individual is minimized. And then here's one of the tagged individuals in a holding tank before we released it back into Lake Superior. The tag has a point where it's allowed to rotate, and it's also with the idea that it somewhat makes it a bit more streamlined or a little bit less drag on the individual. We had a few tagged fish that we kept at NADF over last summer, and just to observe if there was mortality or stress, or I really couldn't measure stress, but any external issues, I guess, with the harness. And really the insertion points for the harness looked no worse than what I've seen from Floyd tag insertions. A little bit of soreness, a little bit of redness, but not that bad. So last year we released a batch of fish from NADF. We were kind of testing the technology, and so a few of the deployments were 1 month, and then a couple of fish were 3-month deployments, and then we have a few that are going to pop off this coming June that were 1-year deployments. We were doing another project out at Isle Royale looking at lake trout reproduction and handling some really large individuals, and so we decided to tag a few of those fish that we captured last August and release them with the tags. They were a short deployment because we knew we'd be coming back in September, and we really want to try to get these tags back. Although it's great that they transmit the data, we will get the data back. If we can retrieve the tag, we can rearm them and reuse them at a fairly minimal cost. And then last fall, late October, early November, we tagged a few more leans and a few Ciscoettes. It was a bit of a struggle to find Ciscoettes of adequate size in the Marquette area for tagging. We caught a lot of Ciscoettes, but not necessarily the size we were looking for. So at the end of the program mission, the tag pops off, floats to the surface, as I told you, transmits data. It also, if conditions on that day are correct, if the skies are clear enough, you'll get a position fix. And over a series you might get multiple position fixes, and that enables you to potentially recover these tags on Lake Superior. The company had shown us where some folks on the East Coast had recovered these tags in the Atlantic Ocean, so we were optimistic that we could recover them on Lake Superior, assuming that the fish hadn't moved, into Ontario waters where it would be logistically more difficult. But once you get the position fix, we used pretty low-tech radio scanners, radio scanning equipment with directional antennas. I'll show you a few pictures of that. And amazingly, to this point, all the tags that have actually detached from the fish, Sean's crew has been able to recover. We had 1 or 2 that never detached from the fish, and we really don't know what happened. But everything that popped off, we were able to recover, regardless of its location on the lake. So typically, you can go on the Argos website, you get some maybe hopefully multiple position fixes, so you have an idea of maybe the direction the tags might be moving due to wind or currents. And then basically go out with the long range antenna to begin with, get a kind of a crude position fix, and as you move closer, we have this directional, like a Doppler direction finder. Really, like I said, really low-tech kind of stuff. It was hard to find this equipment because it's just this equipment, they don't sell it much, like through Radio Shacks or anything like that, but we were able to track some down, and it works relatively well. And then when you're within distance, hopefully, I should mention the transmission rate is every 1 to 2 minutes, so you have to be kind of slow and steady with it. You can actually overrun your detection if you're in too much of a hurry, but then it's really just searching the water for a pretty darn small target. I mean, we're talking about what really sticks out of the water is a target maybe the size of a baseball, if you're lucky, more probably closer to like golf ball size. So I'm astounded. I haven't been on one of these missions yet, but I'm just astounded that Sean has been able to recover these tags so far, and we're hopeful that we'll continue to be that successful. And here he is with another successful mission. So I showed you we're like in the middle of this whole project. We have some data that has come in, but I thought it would be really cool to share some of it. And it's kind of going back to like, oh, look at the 1 or 2 examples of the data. But we didn't just grab the most extreme examples. A lot of the depth information that we've received so far is strikingly similar across individuals. So I just grabbed a couple of them. We haven't summarized anything yet, because we're really not at the stage where we have enough individuals to do so to make real meaningful conclusions. But still some food for thought from some of the preliminary tagging. So this is a hatchery Siskoet that was released off of Marquette. It's a 3-month deployment, so along the x-axis is date, and the tick marks are every 7 days. And most of these plots will be aligned so that the top of the plot is the surface, and then descending down from there, and it's in depth. The depth is in meters. So this hatchery Siskoet was often inhabiting over 90 meters of water, but then you have these periods of anywhere from a few hours to over the course of 24 hours where they're moving throughout the water column. From the bottom, conceivably the bottom, we haven't paired this with the geolocation information yet, but conceivably near the bottom to the surface, near the bottom to the surface. And then in this fish, it was a bit exaggerated, these periods of relative inactivity in terms of depth distribution. And we saw this over and over with the fish so far, and Rick has kind of coined it, it's like a food coma. You've got these periods of activity where presumably they're encountering prey, they're feeding, and then possibly kind of staying in a relatively similar position while digesting that prey. If you zoom in and kind of grab just some of the typical 24-hour periods, which is what these are, it's from midnight to midnight, oftentimes the fish was at or about 90 meters, but then there's these excursions towards the surface, often during the evening or during the middle of the night. But then you have almost entire 24-hour periods where the fish didn't change depth. Again, until we pair that with geolocation, we don't exactly know if it was cruised horizontally in the same depth and covering a lot of area, or if it was simply in fairly static movement. If you contrast this with a wild Siskoet that was tagged off Isle Royal, you can see that this fish was exhibiting a lot of the same behavior with periods of activity within very short duration of time up and down in the water column, and then periods of inactivity, possibly this food coma kind of phenomenon. This fish, probably partly due to the location and access to very deep water, you can see it's venturing in, to at times well over 200 meters of water. If we zoom in and grab a couple of the 24-hour periods, this one was a little bit strange because, like the upper left, it was inhabiting fairly shallow water for a good portion of that particular 24 hours, but then it seemed to be diving down and throughout the water column. But quite a bit of diversity in even though they're making these movements, as we certainly suspected, there's a lot of evidence that they were making these vertical migrations. It's not quite as uniform or as regular as I think maybe we expected. And then finally, just to show you, this is a wild lean kind of just as a juxtaposition with the Siskiyou. And there are some, and this was at Isle Royale also, which I think, again, area is important because it's a stone's throw into very deep water off Isle Royale. And so this lean occasionally made some excursions into relatively deep water, at least as we would suspect for a lean morphotype. But generally speaking, spent most of its time in water less than 50 meters, which, again, really what you might expect. And again, if I just zoom in on the 24-hour periods, the occasional excursion into deep water, but relatively shallow distribution. Another cool thing we just started looking at was because the tags have a solar panels on them, we have a relative measure of the light that it's receiving, and so you get it's not measured in lumens, but it's a relative measure of light. And so these dots are, the gradation on these dots, which is the same depth information, they're graded by the amount of light. So the more yellow, the more light that the tag was receiving at that particular depth location. When you look at this happens to be one of the leans that I just showed you. Not surprisingly, if it spends most of its time in that photic zone during the day, it's receiving a lot of light. But I wanted to show you this so that when you look at a Siskiyou, it's a very different picture. Looks like the first few days maybe there's some wacky behavior due to the stress. There was spending a lot of time up near the surface during daylight hours. But after that, all the excursions to the surface were happening under very low light conditions, almost no light, so at night. So it's kind of a quick and dirty way to kind of dig in. I mean, we can look at this, and we will, by hour of the day and all these activities kind of bore down into it more, but this is quickly, you can see that they're just not making these excursions during the day. So, 2015, upcoming, we have a few different batches of fish that will be released or popping off that we'll need to try to recover, or at least we'll be receiving the data from. We plan to release another batch of fish from NADF, so the hatchery fish, the hatchery lot will go out again off of Marquette. Like I said before, it was a bit of a struggle to capture Siskiyou, so we're looking maybe to tag a few more fish off Isle Royale via this reproductive study that we've been doing out there. We've been handling just gigantic Siskiyous, much larger than you typically see about anywhere else in the lake, and so they may end up being our test subjects rather than struggling to find them around the South Shore. That's what I just said, and of course, as more tags begin to roll in, it's the same sort of situation as the acoustic arrays, where if we have data being collected every 1 to 4 minutes over the course of 12 months, we're getting pretty buried in data. But looks like Rick is going to have a student or two kind of devoted to this project, trying to make sense of a lot of this information. And lastly, I just mentioned the geolocational information. We initially thought the resolution would be relatively high. We've come to find out that may not be the case for especially the Siskiyous, because they're spending most of their time in too dark of conditions to get a really high resolution from the sun's position. But we also have been working with Desert Star with like a calibration that hopefully will improve our resolution for geoposition. So if we've got a few minutes, I'm happy to answer any questions that I can.